Welcome to my demo of my deep learning model to learn and reproduce original classical music. This model uses Python and Keras to train on music as MIDI files and output original music based on what it has learned. As we open up Logic or GarageBand or any other software to create music, we can drag in a MIDI file to see how it stores musical notes. In this demo, we'll be training on classical music from the composer Chopin. Here, there are 3 tracks, but we'll only be training on the one which is in the middle with a sequence of notes going up and down. We first have to parse this MIDI file to extract the track we want. We'll then use the Music21 Python library to extract individual notes and chords from the MIDI file. As you can see below, the notes are printed as they would appear on a piano, notes A through G, with a number corresponding to which note it is across a piano from the lowest to the highest. Now that we have a dictionary of our notes, we can create sequences from the song we're training on. We can use different lengths of sequences, which we'll later see will have an impact on the music we output and how well it learns. As our input, we're going to create a sequence, and then use the next note after that sequence as the label that should be predicted, since after all, music is based on a sequence of notes and progressions, each leading to the next. Now we'll actually create the model. We'll use a sequential model for Keras, with 2 LSTM layers with dropout, leading to a dense layer which has our vocab length of potential notes we could possibly output. We'll use categorical cross-entropy as our loss, so we'll output probabilities of each note in its corresponding one-hot encoded location, and we'll train with 200 epochs to ensure that our data is learned well. Since we're only training on one song, this will technically lead to overfitting, but training on many more songs at once would help solve this problem so that the model can generalize better. To generate new music, we create a backwards dictionary of notes with the corresponding one-hot encoded location as the key. We'll then iterate through the number of notes we'd like to output as our song, here 100, and use the model to predict a new note each time. Since it outputs probabilities of each note, we convert this to typical one-hot encoding by choosing the note with the highest probability as 1 and all the others as 0. Now let's listen to our actual output. This song was trained on a sequence of 20, and as you can see, it sort of gets stuck here and predicts the same note a few times in a row. Now we'll look at a sequence trained on a sequence of 50. This one doesn't get stuck, and as you can see, even changes keys a few times. Now let's look at something that was trained on an entirely different song. And that's my demo. Thanks for watching.